Hey there, this is Akshit Madan and welcome to a new video. And in this video, we are going to explore a new Kaggle dataset that is about mobiles. So if you are new on this channel, you can like our videos and subscribe to my channel. So without wasting more time, let's go to the Chrome and let's explore this data, that is mobile price classification. So this data is uploaded by Abhishek Sharma. So thanks to the author, and this is the data on which we are going to perform some analysis and a model building, that is KNN. We are going to build a KNN and predict the accuracy, and we are also going to predict the values for test.csv file. So as you can see, there are two files, train.csv, on which we are going to predict the prices that we are going to perform train test split, and we are going to divide the data into two half. And after that, when we'll get the accuracy, good accuracy of KNN, then we are going to perform predictions on test.csv, right? So now let's go to my notebook. I'm using Kaggle kernel. Okay, so here is your data. As I've already told you many a times, that from here you can copy the path like we do in Google Colab. First we upload, but here it is already uploaded, right? So let's yeah, first of all, I'm importing NumPy and pandas. Then I am importing Seaborn and Matplotlib for visualization purposes, right? And after this, I am creating a data frame, and I am pasting the path that I've copied from there over here, and then I'm reading the CSV file. So first of all, I am reading the train.csv file, right? So, and test.csv file, we are going to perform it later, right? So this is the data. So as you can see, and the meaning of each and every column, like battery power, you can understand, clock speed, dual sim, but what is FC, what is 4G, you can understand, memory is there, MDEP, what is MDEP. Now everything I have copied and I have explained over here, like in attributes, right? So you can, if you don't understand any column, you can just come over here and you can see. So px height is pixel height, px width is pixel width, RAM random access memory, sch is screen height, screen width, like this. So I have already copied it, so for your purpose you can just refer it there. Now after this, I am printing the shape. So as you can see, 2000 rows versus 21 columns are there, right? So there are 21 features, out of which one feature is our answer, that is price range. So we have to predict between 1 2 and 3. I think 0 is also there, 0 1 2 and 3, to which category our mobile belongs to. Like 3 category is the topmost, like the highest prices mobiles are there, 30k and more than 30k, like this. One means 10k, I think, I'm not sure, but according to me it is 10k, 20k and 30k mobiles, right? So after this, I am printing the describe function, df.describe, and as you can see, this is my data. So maximum battery power is around 1998 and minimum is around 501. Like this you can analyze from this table also, right? So then I am printing df.info to check whether I have any null values. So it's a good news that we don't have any null value, right? 2000 rows are there and every row is non-null value, right? So it's good. Then after this, I'm plotting a heat map and printing the df.core function, that is correlation function of my data frame. So it is going to print the correlation of each and every column with against each other for my easy purpose. Like I can get like this is my price range. Now I can get to which other column my price range is having good relation. So I can see that battery power is having a good relation with price range. Then I can see rest are a little darker. I'm just finding the lighter ones, so because according to my SIBA, lighter one means good relation. So RAM is having the very good relation, right? Px height and px width, that is pixel height and pixel widths, are also having good relation. And price range, of course, it would be having a good relation, right? So let's visualize this data. So first of all, I'm plotting a relation between price range and battery power, because you can see that battery power is a little lighter than the other columns, right? So I'm printing a relation between visualizing the relation between price range and battery power. So for that, I'm printing a plt.figure and give it and I'm giving it a figure size of 12 by 6, and then I'm plotting a bar plot with x data as my price range and my y data as the battery power, and data is my df, that is data frame. And so as you can see, this is my plotted graph. So you can see that the mobiles which belong to the price range of 3, that means more than 30k, are having a very good battery power, like more than 1200, are belonging to three category, because they are the costliest, right? So they must be having a good battery power, so we can visualize it. And the price range of 0, is having the lower battery power as compared to other price ranges, right? So it was expected only, so we can visualize it also, right? So let's go to the next thing, that is I'm plotting a relation between price range and the pixel height width. So we have already seen that there is a good relation between price range and pixel height width. So I'm visualizing it also. So I am using subplot because I want to plot two graphs, and I'm giving it one row and two columns. So one row and two columns. I've already explained matplotlib basics in my previous videos, right? So I'm plotting subplot, and in first plot I'm giving position as 1, and in the first plot I'm plotting a bar plot with x is my price range, y is my pixel height, and data is my data frame, and palette is I'm using reds for this graph, right? So price range versus pixel height. So as you can see, the mobiles which belong to third category are having the highest pixel heights, like more than 700, more than 750, and the mobiles which belong to zero category, zero price range category, are having the lower pixel heights from around 525, right? And same thing is happening with the price range and pixel width. So more the price, more the pixel width, right? So it was expected, and yeah, we have got the expected thing also, so good. So let's come to next thing, that is I'm plotting a relation between price range and RAM, random access memory, right? So I can see that the I'm also using matplotlib dot figure size 12 by 6. X is my bar, I'm using a bar plot. X is my price range and y is my RAM. So I can see that the mobiles which belong to third category are having the higher RAM, and the mobiles which belong to zero category are having the lower RAMs, right? So it was also an expected thing. Next thing, I'm plotting a relation between price range and 3G slash 4G, because I wanted to see that first of all, I'm plotting a count plot for DF at 3G. So I want to see how many 3G mobiles are there. So I can see the 1 means the mobile is 3G and 0 means the mobiles are not 3G. And hue, I am giving a data frame at price range. So hue is going to differentiate between my this column, like among the 3G mobiles, how many are having how many mobiles are belonging to third category, to second category, first category, and zero category, right? So I'm giving a palette of pink. So I can see that the mobiles which are belonging to 3G category, that means this whole plot, among this whole plot, this category, that means the last building is belonging to the third category. You can see from the legend, right? So I can see the mobiles which belong to second category are highest. So as you can see, this building is the tallest. So the mobiles which belong to 3G category, that means the mobiles which are having 3G facility, and they belong to second price range, right? Maybe third, you will be thinking that why not the mobiles having 3G feature are not belonging to third category, because time has gone of 3G, right? 4G mobiles are more in the market. So maybe we can see in the next plot where I'm plotting price range versus 4G. There you can see that the 4G mobiles are having higher counts, right? So this was for 3G. Now this is for 4G. So as you can see, same thing I've done. I've just changed the column name. I've changed it to 4G, and hue is again price range, and palette is my ocean. Right. So as you can see, as I told you that the mobiles which belong to 4G category are and they mostly belong to third category. That means they are the costliest mobiles, right? So this building is the tallest in this whole graph, and these mobiles are not belonging to 4G category, right? Then let's come to next relation. I'm plotting a relation between price range and memory. That was int memory column is there, right? So and here also I have defined a hue as dual sim, because I wanted to know how many mobiles are having dual sim feature, right? So I can see that first of all I have given x as my price range. So this is my price range. So this is a line plot, right? So this is a line plot, but there is no such category of 0.5, 1.5, but just it is a continuous graph. That's why it is plotted like this, right? So this is my price range and this is my int memory. So I can see that the mobiles which are having dual sim facility, that is one, that is orange line. This is the orange line, right? So the orange line and the mobiles which belong to zero category, that means they are the cheapest, are having lower int memory, right? So as you can see, and the mobiles which are having which are belonging to third category, that means they which are the mobiles which are the costliest, are having a good int memory value, right? And the mobiles, now let's explore the mobiles which are not having a dual SIM functionality. So the mobiles which are not having dual SIM and they are the cheapest, they are having good memory, maybe because they have good memory, that's why their price is high, right? Because you can see that their both the prices are same. And why the price of mobiles which are having dual SIM is equal to the mobiles having not having dual SIM? Because there is a difference between int memory, right? That's why they are same, because the mobiles which are not having dual SIM are having good memory, and the mobiles which are having dual SIM functionality are having lower memory. So it is almost same because it is cancelled, right? So that's why their value is same. They are below, they both belong to zero category, and same thing is happening at each and every point. So at the end also, the mobiles which are not having dual SIM are having good memory, and the mobiles which are having dual SIM are having lower memory. That's why their price is same. So this is the visualization I've got. Now let's go to data pre-processing part. So first, from the X, to build the X value, I'm dropping the price range because that is to be predicted by us and by our model, and I'm giving that value to Y, right? So Y is our output. So I'm now importing train test split from my model selection, and I'm splitting the data with my test size as 0.3, right? So pre-processing is done. Now let's go to KNN. Now from sklearn.neighbors, I am importing kneighbors classifier. I am storing the classifier in this variable knn and with my n neighbors as 10, and I am fitting the data xtrain and ytrain. So it is going to fit my data in my model, and then I am printing the score, which is coming a very good, which is a very good score, like 94.5 is a good score. So this is the score that has come from my xtrain and ytrain fitting. Now I am predicting the values for X test, right? I am storing all these values in predictions variable. And coming to the next part, I am printing the accuracy score. So first of all, I am importing accuracy score from metrics, and I'm printing the accuracy score, which is also coming good. That is 93.5%. So our model is actually a very good model, KNN model, right? And then let's import the test.csv on which we have to perform some predictions, because this test.csv is not having the price range column, and we have to add that in our file. So this data we have got. So first of all, I am from here. So as I have told earlier, like these are two. We are given with two files. So first of all, we took the train.csv. Now you have to got test.csv, right? So in test.csv, as you can see, there is no predicted price, sorry, the price range column is not there, right? We have to add that. So this is the head part. Now the shape part, as you can see, 21 columns are there, but because this file is having an id column, we have to remove it, because as you can see, just a second. Yes, because as you can see in train.csv, there was no ID column, right? And still it was 21 columns because we had this price range column. So we have to perform that same thing on train test.csv also. We have to remove that ID column, and we have to make the shape same, because model is expecting 20 columns only, right? So we have to remove this ID column. So that I'm doing the same thing. I'm removing this. I'm dropping this ID column. So we have got 20 columns, and now we can add the data in our model. So I'm saving this knn.predict test df, that is this data, test.csv data predictions in my variable, right? And then I'm adding a column name to my data frame. This data frame, I'm adding one column with the name as predicted price, and I'm giving this value as test pred, like this, which is holding the predicted values for my test data frame, right? So now if you will see the head part, now you can see that this predicted price is added in my test data frame. So these are the predicted values that we have predicted. We were not given this value. Our KNN model has predicted this, right? So these are the attributes to help you if you got stuck, if you get stuck, if you don't get the meaning of any column. So this is for you. And yes, this much for this video. And till the next content, keep coding, keep innovating, and thank you.